Hey, guess what? Today we get to do a new math warm-up. And this one I'm really excited about. I think you're gonna like it. Before we get there though, let's do our normal. Let's update our calendar grid and update our calendar collector. So here we go. Today is September 17th, and here's what our marker looks like. Wow, that pattern is really growing. Right, I have a scroll, have 8 heel bones, and 7 staffs. You know what that means? We need to figure out the equivalent modern number. And we can think in terms of an expression, like we did yesterday. So we have 100 plus, we have 8 heel bones, and each one is worth 10, so that's 8 times 10, which is 80, you got it. So now we have 100 plus 8 times 10, which is 80. So 100 plus 80, plus we have 7 times 1. So what's our total? Right, 187. Let's update it. All right, so 187. Does it still seem to be following the pattern where we're adding 11 each time? Yeah, and so if today is the 17th, because it's September 17th, and each day it seems like we're multiplying it by 11. If you haven't figured that out yet, then that's a really big hint for you. Then maybe we could figure it out just knowing our 11 times tables and not necessarily always looking at the calendar marker. But I will say the pattern may change again. So we got to stay on our toes. Now let's update our calendar collector. Since today is the 8th day of school, here we have 6, which completes 1 whole yard. We added 1 yesterday. We're going to add 1 today. All right, so what does that mean? How many inches do we now have? Take a second, think about it. So how many inches? 8 times 6 is 48, right? Each time we are adding 6 because every day we're adding 6 inches. So now we have 48 inches. So how many feet is that? Did we just complete another foot? We did. Now we have 4 feet. Do you guys see a pattern here? A half, a hole. 1.5, 2 holes. 2.5, 3 holes. 3.5, 4 holes. Do you see it? I hope so. Well, what about yards? How many yards do I have? Good, I still have 1 whole yard, and now I have 2 6. Or I could say I have 1 and 1/3. I could also say that I have how many 6 pieces now? Right, 8 6. Very good. All right, now for our brand new math warm-up. I'll tell you what it's called. Maybe you've heard of it before. A problem string. Have you done one of these before? I'm excited about it because we get to do some connected math problems where we'll use some of what we've already done to help us figure out what's to come. So in your Number Corner workbook, you have some dedicated problem string workspaces, and it looks something like this. And it really starts probably in the appendix, which is after page like 95 or 96. So I want you to find that page really quickly, and I'm going to give you a moment to do so. Okay, are you there? All right, let's get started. So, just to reiterate, a problem string is a series of connected problems. And you'll solve them, we'll discuss them, we'll talk about strategies that can be used to solve them. A lot of times they start out really easy, and then they get harder as the string continues. So, the good thing to note is that the problem that we start with is usually one that's going to help you solve the problems that we're going to get to towards the end. So I'm going to need you to think like a mathematician, because the goal is to find really efficient ways to solve problems. And you may remember me talking about efficiency earlier this year, maybe last week sometime, since we're still brand new into the school year. And efficiently just means quickly, but also accurately, so you can arrive at an answer really fast and get the right answer. So that's what we're focused on. That's what the goal of these problem strings are. Okay, so you have your notebook open. I'm going to go through the very first problem with you. Go ahead and date your page at the very top left-hand corner, or you can use the right-hand corner. Today's September the 17th, right? We did look at our calendar today. All right, so September the 17th, date it, and you can even put problem string 1. That way, as we continue to work through other problem strings, you can use any of the unused space on these pages. We don't want to waste any, right? Okay. So here's the problem. It says, yesterday at my friend's school, there's some 5th graders who were planning a school garden. They were planning where to plant some flowers for butterflies, and they outlined a 5 by 8 foot plot. To know how many seeds they need for the flowers, they have to figure out the area of the plot, which is how many square feet are in the plot. What is the area of the plot? Just as a refresher, you may have heard the term area before, or at least you should have in 3rd grade. I want to give you the word resource card for area so that you can just refresh your memory really quickly, and then we'll start to solve the problem. Okay, so area is the space inside of a shape. It covers how much space you're going to need to cover an area. So you can think about it like a rug. So if you're going to put a rug or some carpet down in a room, you need to know how much carpet you need to fill up the entire floor. Okay, so they're trying to plant a garden, and they drew it a 5 by 8 plot, which means here is our problem. And I'm going to zoom in actually. And I want you to, whatever I write, I want you guys to make sure you're also recording in your notebook. So I'm going to write, let's start with 5 times 8. 5 times 8. That's what we're starting with. And I'm going to put it right here, top corner. Okay. Go ahead and pause this video so you have a moment to draw a picture to solve it. All right, did you draw your picture? Do you have your answer? What'd you get? I'm making my 5 by 8 here as well. So what is the area of this 5 by 8 plot for this garden? 40. How'd you get 40? You just knew your 5 facts? Great, and if you don't know your 5 facts, you can easily count by 5s 8 times. And we'll talk about some other strategies that could have been used as we go throughout our problem string. Okay? Okay. Well, here's our next problem. The 5th graders, they buy the seeds, and the seeds come back in some very big bags, and then they realize that they could plant a much larger plot. So if they made it a 10 by 8 instead of the 5 by 8, how many square feet would they have to plant their seeds? So here's our next problem. Right, go ahead and try to work that one out in your notebook. Right, are you finished working it out? How'd you solve it? Okay, so you got 10 times 8 is 80, and you just knew that fact? That's good. Did anybody solve it a different way? Oh, so you used 5 times 8 to do 10 times 8. Here's what that may look like. Does that look like 10 times 8? It's 5 plus 5, 10. Right, so what is 10 times 8? Good, 80. I'm going to put that right here. Okay, let's think about what just happened. You guys just solved the problem. Some of you shared your answers. You just knew the fact of 10 times 8 is 80. Some of you may have used what we've done with 5 times 8 to figure out 10 times 8. And you shared how you got the answer, and I just simply recorded it up here. This is going to be a part of the routine that we are going to do when we do problem strings. So we're going to do the next few problems, and I want you to stay with me and to continue to use the thought of maybe using a known fact to solve an unknown fact. And if you just know the answer, then that's okay too. We'll record it that way. Okay? So now the students expand the plot again. I guess they realize they have a lot more room than they originally thought they had. And now they have 10 times 16. Go ahead and solve that problem in your journal. All right. I want to remind you that we're looking for efficient ways to solve the problem. So, how'd you solve this problem? Yeah, it does double this time. So last time we started off with 5 times 8. We doubled 5 to get 10. I'm writing it sideways, so hopefully you guys can kind of see what I did there. So now you're saying we're doubling 8 to get 16? Is that right? Okay, so here's what that may look like. I'm going to erase what I did here. Maybe I'll still leave that. That's still 80. And I'm going to add another 8 here. 2, 4, 6, 8. And we have 10 going down. So this is actually a 10 by 16. So again, we're trying to find efficient ways to solve problems. So then 10 times 16 equals what? Right, 160. Okay, so we doubled one factor and the product doubled. For the third problem, we doubled the other factor and the product doubled. Right, so if one factor doubles, then the product doubles. I'm going to say that one more time. If one factor doubles, then the product doubles. And let me just show you what I mean in case you don't understand. First we have 5, and then we went to 10, which is doubling. That's like multiplying it by 2. So if I double one factor, then look what's happening to my product. My product is also doubling. For the third problem, and that's supposed to be a multiplication sign. For the third problem, did we double 10? No, we doubled 8. And look, our product doubled. Good job. That's a really good observation. Okay, so now I have another problem for you. Let's see. This time, they try a different arrangement. 5 times 16. Work that one out. How does 5 times 16, though, relate to 10 times 16? Right, it's half as much as 10 times 16. You're right, because 5 is half of 10. So are you saying if we're going to split one of the factors in half, then the product is going to also split in half? Let's try it. I'm going to draw that. So we know this is 16. This time I'm only going to do 5. 16 and 5. So what is 16 times 5? Well, this whole thing was 160. So half of 160 is, right, 80. You guys are on a roll today. And I'm just going to record this just a little bit differently so that you guys can really see what happened. So earlier we had 10 times 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we knew that that whole thing was 160, right? So I'm just redrawing what we drew up here. So 8 and 8, 16, and then we have 10 total. Well, essentially what I'm doing, instead of doing 10 times 16, doing 5 times 16, I am cutting this shape in half. Can you see it now? So now instead of having 10 times 16, now I'm only focused on half of that, which is 5 times 16. Okay, I heard someone say they noticed that 80 is the same product as 10 times 8. And you're right. But how can that be? I'm going to show you. So pretend that this is my paper. It's 8 by 10, right? So here's an 8 by 10, which has an area of 80. So if I were to take this 8 by 10, and now I'm doing 5 times 16, essentially what happens is I'm splitting my 10 in half. So I still have 10 if I put them together, but now I have 5 plus 5. And along this side is 8, which means along this side is 8. You see that? So if I just slide it on top, now I have the same area. I didn't add any space. I didn't take any away, but now I just rearranged it to look a little different. Do you see that? All right. So let's keep going here. Wait a second. What was that? You also noticed that it was two 5 by 8s. So this was a 5, and this was 8. Remember, I split my 10 in half, and I had two of them put together. You're absolutely right. I can show that on my picture like this. Remember, we have 40 here. And then that means 40 would also be here because this would be 5 times 8 plus another 5 times 8. Great thinking. Okay, we got a couple more. The next one looks like now they're having a 15 by 16. I guess they really can't figure out what they want to do, huh? How does 15 times 16 relate to the problems that we've done earlier? Good. So, and I need to put 5 times 16. Let's go ahead and put our product there, make that full equation. Okay, so you're saying that we already know 10 times 16. So what's left over? Right, 5 times 16. So if I want to find 15 times 16, then what could I do? I could add these two products together. Let me show you that. All right, I'm going to show you that. So we have 15 times 16. And you guys just said earlier that we had already solved we already solved what? Right, we already solved 10 times 16. That's the wrong one to use. And we've also solved 5 times 16. Do you see it now? We did our 5 times 16, which was this long thing put together because we split our 10. And then we had a 10 by 16. So what do we do to find the product? We add them together. So this is just another visual to show you exactly what's happening. And so if I am going to add it together, then I have 160 for 10 times 16 plus 80 for 5 times 16, which gives me what? Right, 240. An area of 240. Okay. Are you guys with me? Does that make sense? Remember, mathematicians are all about efficiency. So we're trying to find a quick way to solve it, but also to make sure we're accurate. And the whole point of the problem string is to start easy and make our way to more difficult, but we can use the easy problems to figure out the more difficult problems. Okay, we have 2 more. The next one is 30 times 8. Whoa. We can draw this, right? Does anybody see a connection, though, between 30 times 8 and maybe the problem ahead of it, 15 times 16? So 30 is double 15? You're right, it is. Well, what about 8? Because 8 is not, it's not 15 times 8. Oh, so 8 is half of 16. I'm going to write times 1/2, or divided by 2, I could also write it. So 8 is half of 16. So we doubled one and we halved the other. Wonder what's going to happen to our product. I'm actually going to draw this one out on our whiteboard here. So maybe we can see it a little more clearly. So we have 15 times 16. And what I'm hearing, so this will be my 15, and it's not as proportionate as I would like it, so I'm going to try to fix that really quickly. Okay, so we knew that 15 times 16 was 240. And what you guys just told me is that in order to do 30 times 8, we had to double 15. So here's my double 15 to get my 30. And we need 8 here, which means we're cutting 16 in half. And I'm actually taking the half from here. So you can pretend like this is going away, or you can envision it kind of moving here. And hopefully this drawing is making a little bit of sense to you. So it kind of goes back to my illustration here, where I doubled one and I cut the other one in half. So this one I'm cutting in half, and I'm just sliding it on top so that my length is now doubled. You see that I have double the amount, twice as long. So first it was just this long. Now I'm doubling that. And now it's this long. It's twice as long. And so what does that mean about my product? Right, if I'm taking this piece off and slicing it and I'm moving it down, rearranging it a little bit, and that means my product should still, you got it, it should still stay the same. I didn't add anything, I didn't take it away, I just rearranged it a little bit to kind of fit what I needed it to. So when you double one and you have the other, it looks like your product is going to remain the same. All right, let's do our last one. 4 times 60. Whoa. How does this relate to what we just did? I started off with 15 times 16, And maybe I should put my 16 up top. So I'm going to put 16 here so you guys can see that, which was 8 plus 8. Okay. And I had to rearrange it because I didn't need 15 times 16. I needed 30 times 8. So I doubled 15. I halved 16. But now I'm asking you for 4 times 60. 4 times 60. It looks like 60 is double 30. And 4 is half of 8, right? So I think I need to do this. So right now, and I'm going to use a different color so you can really see. Maybe I'll use black. Right now I have a 30 by 8. Do y'all see that? Okay, great. Well, now I need a 60 by 4. So I'm going to cut it in half here. And I'm going to slide this piece down here. So I'm kind of cutting this piece off again. And I'm moving it. I'm moving it this way. So now I have 30. And instead of having 8, and I have another 30 here. And it looks like I have 4 instead of having 8. Do y'all see that? Let me show you in using my paper model again. Okay, so I start off with, I think it was, 15 times 16? And then I cut 16 in half, so now I have 8 and 8, 15 times 8, 15 times 8, and I moved it here. Okay, do y'all see that? So now I had 30 times 8. Well, if I need 60 times 4, what's actually happening is I am carrying my 8, and I am making a really long and skinny, it's kind of hard for me to hold it all up, but I'm making a really long and skinny area. Okay, that's what's happening. So then, what's happening with our product? Right, our product should stay the same. So if I were to ask you to summarize what you've learned today, what might you say? Right, that when you double one factor, the product doubles. When you have a factor, the product is cut in half. But if you double one factor and have the other, your product is going to remain the same. I'm going to say that one more time. If you double one factor, leave the other factor the same, you're doubling the product. If you have one of the factors and the other factor is the same, you're having the product. But if you double one factor and have the other, then your product is essentially staying the same because you're just shifting it around and rearranging. Wasn't that fun to think about? The more we practice, the more we stretch our brains and make the effort to think through what's really happening behind the mathematics, the better at math we're going to get and the more efficient we're going to become, which is our goal as mathematicians. Thank you for today. You've done great. I really appreciate it. I'm going to see you tomorrow. Bye-bye.